Bonjour à tous. Welcome everyone. So we are here today for the last day of Inforce to be able to talk about Agentic AI identity. So I hope that you are thrilled. We have a lot of good content for you. There will be more content during the days that can allow you to deep dive into that. But let's start maybe with like this very small and rapid talk about that. My name is Jeff Lombardo. I'm a security specialist. I'm based in Montreal, Canada. And with me today is Fei.
Hello everyone. This is Fei. I'm a principal engineer. I'm a principal engineer in AWS on the service team. I own the design and implementation of Amazon Cognito, which is an identity provider service. Thank you.
So the first thing that we want to do today is to come back a little bit onto what happened over the last year and what is in front of us for Agentic AI and generative AI application. Because it's going very fast. In 2023, what you have done is that you might have started with some POC in order to try to assess what the technology was capable of providing to you. This year, in 2024, 2025, you are currently transforming those POC into projects to try to get more value out of your data to maybe like improve the efficiency of both your workforce users and your consumers into the way that they can use the services that you are providing as an organization or the services that you are providing to your consumers. But the main objective is to continue into this increasing optimization of the loop in order to provide even more value to them. What you want is to reach a stage where you will be able to pioneer new ideas and new capabilities into your system because your end user will be able to express their needs through that. So at AWS, what we have done is that we are providing you with a large set of tools that can allow you to create your own GenAI application. Okay, so you can use like Amazon Bedrock, you can use those guardrails, you can use like plenty of elements like the last open source SDK strands that we have released for creating Agentic AI component. But into Bedrock, we want also to give you the choice about the large language models that you want to use. Because you might want to use something general, which has been trained onto a large amount of data, or you might want to use some more specific large language model, especially if you want to tackle the multimodality of interaction in between your user and your GenAI application. And therefore, you can use like model from Amazon, but also from our partners, like, for example, Anthropic, into this ecosystem. In some case, because we are doing that for a very long time and we have a very strong expertise into the compute, we are capable of providing to you the ability to create your own model, to train them, to fine-tune them, to match your exact needs in the matter. For sure, security is our top priority. So the ability to be sure that you are controlling the data perimeter, that you are like putting guardrails around those large language models, that you can maybe access those large language models privately within your own VPC and your own AWS ecosystem is very important for you, and we want to be able to support you into that. But we also know that the generative AI ecosystem is moving very fast, and we saw a lot of open source solution getting out. So we want also to be able to provide to you the interoperability in between those open source solutions and what you will build on AWS. So if we look at a standard GenAI environment for our customer, we can see that when we are decomposing a GenAI application, we can find the same amount of component within it. We need a user that will access our GenAI application, like if it was like a traditional application, and this user will need to be authenticated. So most of the time, there will be an authorization server or identity provider that will be in charge of authenticating those users. Now that the generative AI application know about the user will be able to provide his input So his question to the generative AI or his ask of action, and the agents that will represent the orchestration within the GenAI application will be able to enrich the information, the input that the user set with some information from the organization that will have been presented into the form of vectors through like a vectorized database. This is what we call RAG. The composition of both the user input and the enrichment that we are providing on top of that will then be provided to the LLM for the LLM to be able to think about it and maybe think about the next steps or maybe of the final response to the user input. For that, you will use effectively all the models that I have talked about into the previous slide. The response from the LLM will allow you maybe to take some action against your external system, like for example, triggering a communication through an email system, through a communication, a notification, all those kind of stuff. But what we have seen when we talk to customers is that there is a lot of untapped data. It means that you have a lot of data silos at your organization that can concern the way your organization operates, the metrics that you got over there, or maybe some consumer information, or in some case for the developer, with some local information that they might have onto their own workstation. And, oh, sorry, wrong slide. And what you want is that you want the ability to tap into those different new data silos. So that's why we have seen the apparition of AI tools. AI tools are here to ease the integration of all those data silos into your GenAI application just in time, when the LLM needs it. So for that, what will happen is that those AI tools will be registered at the LLM for the LLM to be able to understand that he has those external capabilities to get more information. What we want to do over here is to be sure that you can create some additional targeted deterministic logic into your LLM, and that you can dynamically fetch for information that can exist externally. Like, for example, if you want your developer to be able to get quickly information about the states of their development, you can have an AI tool that will allow the GenAI application to talk to the GitHub service, look at a specific GitHub repo, and maybe get information out of this GitHub repo onto the last commit into that. So what we are doing, what we have presented into the code talk is that, for example, we can have a customer that will create a generative AI application for travel agency, for booking travel. So the user will authenticate, he will pass the token to the agent, because the agent knows about the different tools that are at the disposal of the LLM. The user, when he will say, book me a trip to Honolulu if there is no weather alert, what will happen is that the LLM will think about that, know he has a weather tool that can allow to get like weather report, and know that he can talk to some travel agency to get travel option and to maybe book a plane ticket to move forward. And those tools will be able to enforce some access control to be sure that, for example, they can use your loyalty profile into those different air travel company in order to book the ticket, and will handle the communication with the back-end service for those different actions to be able to operate. Okay? So what we want, and to return the response to the user. So all those elements will allow you to do like authorization in depth by having a scope that will be like built along the way while you are going through all those different elements. You will be able to like really control what is happening into your generative AI application. So for that, we have a new specification, which is the MCP specification, the Model Context Protocol. This specification is allow us to standardize how effectively the AI tool can present, expose which capabilities they are capable of, and also work into the whole delegation of authorization process that I have just described, using the O2 delegation of authorization, token exchange, and also capabilities like dynamic client registration. But now I want to pass the hand to Faye, for Faye to explain to us how both of those elements, so the mental model I just described and the MCP specification, can be applied on AWS.
Thank you, Jeff. So I got a lot of questions in the last several days from customers and asking about MCP, Model Context Protocol. You probably have heard about it. That's something that Anthropic has been working on, and that's a way to make agents more powerful in making all the tools available for agents to use. So then one of the main questions that I heard is that I want to be able to use MCP, so customers want to use it. On the other hand, they're also afraid of using it. So there's an in and out kind of relation on how do I use it, but without getting trapped or without getting a security problem with it. So I'm going to go through the slide that Jeff showed you a little bit earlier on a sample scenario on how this works, how you will build an agent application, how do you secure that. The example here that I'm using will be using Amazon Cognito as identity provider. For those of you who don't know, it's identity provider authorization server for users to sign in using different ways, password, emails, multi-factor authentication, passkey, and etc. It also supports workload authentication, which is one of the reasons why this is a good piece in the puzzle. But the same diagram here that we're showing you can also swap out with any identity provider. So we are showing you more of a pattern on how you build and how you secure an AI agent. You look at the diagram here, there are a couple components. So when you think about AI agent, there is a user. The user has an identity provider, and then you have an agent. Agent here usually runs an MCP client. That's as part of SDK, part of the MCP protocol. And you have a large language model, which does pretty much gives you the brain and gives you instruction on what the agent should do. And then you have the weather tool, travel agency tool. Here's the MCP server, which is, you can look at it as an API gateway. And then you have the service behind, which are resources. So think about this as a chain of 4 parties acting together. It's a chain of invocation. Don't think about it just one. And that's the reason, as I will show you over the steps, there's different hops require different ways to authenticate and authorize. All right, so the first step is that when Alice wants to access an agent, want to use an agent, let's say you build a chatbot agent, or in this case, it's a booking agent, the agent will ask Alice that please sign in, because the agent needs to know who the user is. So this is a typical OpenID or OAuth type of sequence. One agent will redirect Alice back to an IDP, in this case, Cognito, sign in, and then Alice will ask Cognito to give an access token for agent to access the weather tools, right? Because in this case, agent is the client, the service that agent wants to access, those are MCP server, those are the next hop, which weather tools. So just pay attention there that we're not saying that agent should access the resource directly. It's going through MCP server. Then the next step is that now agent has this access token. It knows about Alice. So it can use this information to interact with the language model, maybe pull information about or just a regular chat. And in this case, it has information about Alice and then just talk to the language model. That's the number 2. And then the third step is that now agent, because agent has the access token, it now can talk to the MCP server, in this case, a weather tool or travel agency tool. And that you will use the access token to access those. All right, the next step is that you have the weather tool that sits in front of the real weather service. And you can think about how would now I have the identity, right? I know the identity that agent is calling me, Alice is calling me, agent using Alice's access token, so the token will have agent information, have Alice information. But then you can do some authorization there. So there's a 2 pattern of how you do authorization. One is that if your resource servers already can authorize based on this type of pattern, for example, taking a token, doing scoping down, then your resource server can do it. But if your resource server on the right side does not have the ability to take in a user or identity, user and agent's information, then you put your authorization server or authorization rules in the MCP server. So think about it as a defense in depth. You have multiple hops where you can scope down the access. And in this case, we're showing Cedar. Cedar is a language, a policy language where customers can write in a more predefined way to say that this user, this agent can access this type of resource. So you write that in a rule way, and then Cedar will run the evaluation for you. And Amazon has a verified permission as a managed service that runs Cedar for this purpose. All right, so the next step, this is getting interesting. When agent wants to access a travel agency tool, and then the travel agency tool needs to access the backend. In this case, you have a hop, right? You have an agent tool and then tool to the real service. We should not be sending the token that agent uses to access the MCP server. In this case, it's the API gateway, or think about it as a proxy. We should not be sending that token directly to asking the travel agency to use that to the backend, right? Because it's a different audience, it's a different audience for the tool to use. So what you will need to do is that then the travel agency tool will do its own authentication because it's an agent of itself. That agency tool will go to Cognito or go to somewhere else, some other IDP, it's up to you. It will run the machine-to-machine authentication so that it proves who it is. At the same time, use the information that you got from Alice, which is a user token, use that information as a metadata or as additional metadata to put that into the claim of the machine token that you get back. So that's a key step. We kind of talked about, maybe in other talks where I talked about delegation versus impersonation. In this case, we're doing delegation because the travel agent tool is acting on its own. It's doing its own authentication and adding the user information. So that's delegation. If travel agent tool is sending the Alice token directly, which is you shouldn't be doing that, then that's an impersonation, right? So in this case, it does that, and then it's able to use this newer token. So pay attention that the step 6 and the 3, they are different tokens. The number 3 is for agent to access whether tool with Alice information. The token used for 6 is the travel agent tool does its own authentication plus the information from Alice and then talk to the backend service. And in this case, number 7, that's number 7 will execute that information, run the authorization. So I was talking about the Cedar or Amazon Verified Permission as a way to authorize. Now you have the information about who is the agent, who is the travel agency tool, which one is accessing it, who is the original user. You have those information, and then the travel agency tool can get this information and properly authorize the request. So I was talking about one of the most important, or maybe the starting point of securing your agent access is think about the resource servers or the resource that agent wants to access. You want to make sure that your information about agent and user get all the way propagated to your resource server so that your agency tool or your airplane API can use those information to scope down. And that's the key of this. Okay, so then here's a diagram of different services of different steps that you can use. Probably you can either take a picture. I will not go into detail on that.
That's the summarization of everything that Faye just presented to you in one slide.
Yeah, it's a lightning talk, so I try to keep it as fast as I can. All right, we kind of jam a lot of information. All right, so delegation impersonation, I already talked about it. Take a look at the client metadata. There's a pre-token generation where you can customize the claim on the machine-to-machine authentication. That will enable you to do this kind of on behalf of work. Okay, I'll pass it back to Jeff.
Thank you. So as you have seen, that's how you are creating Agentic AI identity on AWS. To do that, and that's what the code talk we got, you can use like the guidance for starting MCP implementation on AWS. We also have like a GitHub repository that concentrate all the MCP servers that have been created by solution architect for AWS technology. You can look at it. We are keeping that up to date. I just want also, like I said initially, highlight the fact that we have released the open source SDK for creating AI agent. This is called AWS Strands that can allow you to ease the way that you are developing those AI agents. For sure, at reInvent, we will have more information and more details about how you can use that. Finally, I want to say that Amazon Q CLI and Amazon Q Developer into your IDE can now support MCP server configurations. This is exactly what we demonstrated into our code talk. Okay, so you can enrich those two tools with extra data, like your data silos that we talked about earlier. Finally, I just want to highlight that there are still some sessions onto the topic happening today. I see my friend over here, Edwardson, that will run a builder session this afternoon. So if you want to get your hand dirty onto that, please join their session. Thank you for that. If you have any question, we will be on the side to be able to answer to that. Have a good day, everyone.